Hello, good day. Today we're going to talk about quadratic optimizations. So this is an application of the quadratic function or the parabola. So problem number 1, it says here, the height h meters of a rocket t seconds after it is being fired vertically upwards is given by the function ht is equal to 100t minus 5t squared, where t is greater than 0. And then we are asked of the following questions, A, B, and C. So let's start with letter A first. How long does it take for the rocket to reach its maximum height? So basically, if we're going to have a simple illustration, if this is our rocket and it is being thrown upward, there come a time that it will reach its peak, alright, its maximum. This is our maximum. Now again, we are asked, how long does it take after throwing the rocket upwards, it will reach this peak or the maximum. So to start, let us try to define first our coefficients. So in our quadratic function here, our a is negative 5, our b is 100, and we don't have the value of c. Now, to get the uh, time that the rocket will take to reach its maximum, we're going to make use of the formula t is equal to negative b over 2a. And again, earlier, we know that our b is a negative 5, no, a 100, sorry. So we have negative 100 over 2 times a, which is a negative 5. It will give us negative 100 divided by a negative 10. It will give us 10. So meaning to say, after 10 seconds, the rocket will reach its maximum height. Now, let's proceed to question B. What is the maximum height reached by the rocket? So again, earlier we are asked to find how long does it take for the rocket to reach its maximum height. And letter B, we are asked at what is the maximum height. So basically, what we are going to do is simply what? Simply plug our values to our equation. So we know that t is equal to 10. So our height at 10 seconds is 100 times, again, our height is 10, at seconds is 10, sorry, minus 5, and then 10 squared. This will give us what? 10 times 100 times 10, that will give us 1000, minus 10 squared is 100 times 5, that will give us 500. So basically, our answer is 500 meters. Alright, let's try to make use of our calculator just to check. So again, we have the function 100, and then we have after 10 seconds minus 5, and again we have 10 squared, and again this will give us 500. Alright, now let's have letter C. How long does it take for the rocket to fall back to Earth? So again, after throwing our rocket upwards, it will reach its maximum, the vertex, and then it will what? Go back down. Alright, and then this time at letter C, we are asked, what is the time? Alright, so how long will it take for the rocket to touch the ground? So again, we know that after 10 seconds, the rocket is in its peak, right? Then again, it will fall down, and then it will reach or touch the ground. So again, we are asked, how long will it take the rocket to fall back to Earth? So what we are going to do is, again, solve this using a quadratic function, quadratic equation, completing the square, factoring, or whatever method you want. So for this example, I will just use the factoring method. So I will write 100t minus 5t squared equals 0. Alright? So the height is 0. We are looking for the time. Now, if we're going to look at here, basically we have common factors, right? So I can actually take out 5t, and then what will remain here is I have 20 minus t equal 0. And then I'm going to equate both to 0, so 5t equals 0. T is equal to 0. The other one, we have 20 minus t equal 0. This will become 20 equals t. So this is the answer that we are looking. Alright, so this is the answer that we are looking. So again, to answer this question, it takes what? It takes 20 seconds for the rocket to fall back to Earth. That's problem number 1. Let's have problem number 2. So the height meters of a ball t seconds after it is hit vertically upwards is given by the function ht is equal to 40t minus 5t squared. And again, we are asked how long does it take for the ball to reach its maximum height. So again, we're going to define our coefficients. We have a equals -5 and then b equals 40. Same thing earlier, to find t, the time, we're going to make use of t equals -b over a, and then -b, which is 40, divided by 2 times -5. This is -40 over -10. This is 4 seconds. So meaning to say, after 4 seconds, the ball will reach its maximum height. Now, letter B. What is the maximum height reached by the ball? So, the same thing earlier, we are going to substitute 4 to our equation. So, we have t equals 4. So, h equals 40 times 4 minus 5, 4 squared. This is 160 minus 4 squared is what? 16 times 5. We have 16 times 5. That will give us 80. So therefore, our maximum height is what? 80. This is meters, right? Meters. Let's go back to our calculator and check again. So we have here 40 times 4 minus 5, and then we have 4 squared. Alright, this will give us 80. So again, after 4 seconds, the ball will reach its maximum height, which is 80 meters. Now letter C, how long does it take for the ball to hit the ground? So again, we are going to let our equation equal to 0. So we have 0 equals 40t minus 5t squared. And again, the same thing what we did earlier, I'm going to factor this one out. I could actually factor 5t again. Then what will remain is 8 minus t equal 0. And then again, 5t equals 0, so t equals 0, and then 8 minus t equals 0, 8 equals t. So again, this is the answer that we are looking for. So after 8 seconds, the ball will hit the ground. So that is for question number 2. Let's have number 3. A manufacturer finds that the profit dollars from assembling X bicycles per day is given by the function p of x is equal to negative x squared plus 50x minus 200. Question A. How much bicycles should be assembled per day to maximize the profit? So again, we are asked the number of bicycles so that the company will have or produce the maximum profit. So first thing to do is again define our coefficients. So A equals a negative 1, B equals 50, C equals a negative 200. So again, to find for x, the number of bicycles, we're going to make use of the formula x equals negative b over 2a. And again, our b is 50. And then we have 2 times negative 1, which is our a. This is negative 50 over negative 2, or this is 25 bicycles. Alright. So again, the company must produce 25 bicycles to maximize the profit. This is letter B. What is the maximum profit? Alright, so if they're going to produce 25 bicycles, what is the profit? So basically, we're going to simply substitute. So if P of 25 bicycles, we have negative 25 squared plus 50 times 25 minus 200. Alright, so we'll just use our calculator to solve this. So we actually have negative 20, let's have negative 25 squared plus 50 times 25 minus 200. Alright, so this will be our answer. This will give us $425. So again, this is our maximum profit, right? Now, letter C. What is the loss made if no bicycles are assembled in a day? So we are being asked if the company fails to produce even a single bicycle within a day, how much money will they lose? So what we're going to do is simply let x equals 0. So we will have p of 0 equals negative 0 squared plus 50 times 0 minus 200. So this is 0 plus 0 minus 200. Our answer is a negative $200. So meaning to say the company will lose $200 per day if they fail to produce even a single bicycle.